Video I'm going to cover the first chapter, which is numbers. So let's start with the first topic, types of numbers. So the first type of number is integers. As we all know, integers are the positive numbers, negative numbers, including with zero. Why I'm emphasizing on including with zeros? Because most of the students do not understand that zero is also an integer, right? So integers are positive and negative whole numbers. For example, it has 0. They have the positive natural whole numbers 1, 2, 3, 4 up till positive infinity, and negative whole numbers -1, -2, -3, -4 till negative infinity, right? The second type of number is a natural numbers. Natural numbers are integers. They are basically integers that can be used for counting, right? 1, 2, 3, 4, 5 and so on. So any number that is used for the counting purpose is a natural number. Why 0 is not included in a natural number? Because let's say if I have these two pens, so how can I count these two pens? 1, 2. So I'm not starting with the number 0. That is why 0 is not a natural number. A number 0, all the natural numbers including with the number 0 is a whole number, right? The third type of number is a rational numbers, which is a very important. Rational and irrational numbers, there are so many questions in the exams about these numbers. So a rational number is a number that can be written as a fraction a by b, where a and b are integers and b is not equals to 0. So what is a rational number? Rational number is basically a number that is written in terms of a fraction, right? You can write a rational number in terms of a fraction where the numerator and the denominator, both the numbers can be integers. These are the integers. They can be a positive, they can be negative, they can be 0. But there is a restriction on the denominator. The denominator cannot be equals to 0. The numerator can be equals to 0, but the denominator can't be equals to 0, right? Alright, so rational numbers include all integers. Keep this in mind that all the integers are also a rational number. Whenever you have given any integer and they ask that is that a rational number? So yes, it is a rational number, because we can write down all integers in the form of a by b. We can write down 0 as 0 by 1. We can write down 2 as 2 by 1. So these are the rational numbers. Okay, all terminating decimals. What are terminating decimal? Terminating, the word terminating says stop. Right? All decimals that terminate or that stop after a certain decimal point, they are rational numbers. For example, 5.81. This is a terminating decimal. They have the decimal, after the decimal point, they stop after 2 decimal points. We can write down as 581 over 100. We can write the terminating decimal as a fraction. Okay, and all recurring decimals are the decimals which repeat a same number or a same group of number after the decimal point. For example, we have 0.6 and this dot represent about recurring, right? So we can repeat the 6, right? Repeating. Okay, this can be written as 2 by 3. They all written as a fraction a by b form, right? Okay, so what are irrational numbers? An irrational number is a number that cannot be written as a fraction, such as square root of 2 or pi. Okay, so rational numbers are written in terms of fractions. Keep this in mind. All integers are rational numbers, all terminating decimals are rational numbers, all recurring decimals are the rational numbers. Now irrational numbers are the numbers that cannot be written in terms of fractions. So we have a root 2, the square root numbers. We cannot write down a square root number as an irrational number or as a rational numbers, and pi is also an irrational number. Okay, so most of the students will get confused that we can write down square root of 2 at square root of 2 over 1. So this is not a rational number. Let me show you guys with the calculator what is square root of 2. Okay, so you can see 1.4142135562. So you guys can easily see that this is not a terminating decimal. It does not stop after a certain decimal point. This is not also a recurring decimal, that it does not repeat a same digit or a group of digit. So this is a non-terminating and non-recurring decimal. So this is an irrational number. Or when we talk about pi, what is a pi? You can see 141592654, again non-terminating and non-recurring. So these are irrational numbers. The numbers which are not rational are basically irrational. So this, all the square root numbers are irrational, and the pi is also irrational. They give decimal that do not terminate or recur, as I already told you. So the decimal places are not terminating and non-recurring. So let's do the first example, 1.1. So we have a question: sort the numbers in the list below into rational or irrational numbers. Show how you decide. Okay, so you have to tell which numbers are rational and which are irrational, and you have to tell how do you decide, how do you know this. So you can see 0.8652. So this number terminates after 4 decimal points. So it is a terminating decimal. It is a terminating decimal. So this is a rational number. Square root of 12. This is an irrational number. 4 pi. This is an irrational number. 67 over 19 is written in terms of fractions. So it is a rational number. Square root of 64. We can write down root 64. It's root 8. Because 8 times 8 is 64. 8 times 8 is equals to 64. So 8 square is basically, this is 8. So we can write down 8 as 8 by 1, and 8 is also an integer. So integers are all rational numbers. So you guys can see this is a terminating decimal. Rational numbers can be written as a fraction. So this number and this number are rational. We can write down this as a fraction. We can write this down number as a fraction, right? Irrational number cannot be written as a fraction. So the square root of 12 is an irrational, 4 pi is an irrational numbers, right? You can see they are not non-terminating and non-recurring decimals. Alright, so let's read the notes as well, that recurring decimals. The recurring decimals are the decimals with a dot, right? Recurring decimals can be shown by placing a dot above the digit. For example, 0.3 dot. So this dot represents that 3 is recurring, 3 is repeating, and 1.3.07 dot. So the dot on the first digit and the dot on the last digit, it means that 307 is recurring, 307 is repeating, right? Okay, an irrational number multiplied by a non-zero rational number is still an irrational number. How we come to know that? Okay, so we have given the examples that an irrational number, if we have an irrational number like pi is an irrational number, so if it is multiplied by a non-zero rational number, it is still an irrational. So it is multiplying by a rational number. 4 is an integer. Integer is a rational number. So when an irrational number is multiplied by a non-zero rational, this number still becomes an irrational. Let's move to the next type of numbers, which is a reciprocal. There are so many questions and exams about the reciprocal, right? So what is a reciprocal? A reciprocal of a number is 1 over the number. So you have to flip the fraction basically. So the reciprocal of a number 3 is 1 by 3. The reciprocal of 1 by 3 is 3, and of 2 by 3 is 3 by 2. The reciprocal is basically a flipping of numerator and denominator, or you can say switch the numerator and denominator, you will get a reciprocal. Like the numerator of the number is 2. In reciprocal, it becomes the denominator. The denominator of this fraction is 3. In reciprocal, it becomes the numerator. 2 by 3, 3 by 1. The number 3 by 1 is the same as 3. So I have told you that in the rational numbers, yes, 3 integers are rational. So if I have a number 2, 2 is an integer and 2 is a rational number. So we can write down 2 as 2 by 1 in the form of a by b in a fraction. So this is the example they are telling us, that we can write down 3 as 3 by 1, 4 as 4 by 1. All the integers can be written in terms of fractions by dividing it by 1, right? So let's do the exercise 1.1. So this sign says we are not allowed to use a calculator in this exercise, right? Number 1, state which of these numbers are number A integers and number B natural numbers. Integers, let's recall, integers are 0, positive and negative whole numbers. Natural numbers are used for the counting purpose. Let's begin. Negative 7, this is an integer. This is not an integer and not also a natural number. 27 is a natural number as well, and it is an integer as well. Root is not a natural, not an integer. This is a natural number because it is used for the counting purpose. It is also an integer. 0 is an integer, not a natural number. Fractions are not in the integers and not natural numbers. This is an integer. So let me write down all the integers. -7 is the integer. 27 is integer. This is not. This, no. This is an integer. 1534 is an integer. 0 is an integer. And -12 is an integer. So natural numbers, -7, negative numbers are not natural numbers. Why? Because we cannot count the numbers as the negatives, right? So the 27 is used for the counting purpose. The number 1534 is used for counting. 0 is not a natural number. We cannot count the quantity by 0. So these two are natural numbers only. Moving to the second question, state which of these numbers are rational, showing how you decide. Only for the rationals we have to show, right? Okay, the first fraction number, 17/20. This is in terms of fraction. So it is a rational number. Why it is a rational number? Because it is in a fraction, right? Okay, it is in the form of a by b, and b is not equals to 0, and a and b both are integers. Okay, so this is a terminating decimal. It stops after 2 decimal points. So this is a rational number. Okay, this is a square root of numbers. So as you can see, root of 2 is root 2 and root 25. We can solve this. Root 2 and root of 25 is 5. Root 2 is an irrational number. When irrational number is multiplied by a non-zero rational, it still remains irrational. So this is an irrational, right? This is a reason we are using over here. Okay, this is again an irrational number because pi is an irrational number, and when pi is multiplying by a non-zero rational number, it still remains irrational. All right, so as you can see, this is the decimal number, right? So it is terminating. It terminates after 1, 2, 3, 4, 5 decimal. After 5 decimal places, it's terminate or it stops. So this is a rational number. All right, so this is also a rational number. Why? Because we have a recurring decimal, 2, 3, 4, 2, 3, 4, 2, 3, 4. It is repeating. So this is a recurring decimal. It is a rational number. This is not, this is a rational number. We can write down root 4 is 2 and root 25 is 5. We can write down this in terms of fraction. So this is a rational number. Root 225, this is 15. This is again a rational number. Integers are rational numbers. Okay, so you can see root 3 is irrational and it is multiplied by a rational, it still remain irrational, or add with irrational, it still remain irrational. So this is a rational number. Question number 3, state which of these numbers are rational, show how you decide. Again, this is about rational numbers. Okay, so the first part A, we have root 169 is 13. Without using calculator, you must know some perfect squares, right? The 4 is a perfect square of 2, like 16 is for 4, 9 is for 3, and 121 is for 11. So you guys must know about some perfect squares, right? You must have to learn these, like root 225, it's a perfect square of 15. 15 times 15 is 225, and 13 times 13 is 169. So you guys must have some idea about the perfect squares, because you're not allowed to use the calculator in this exam, in this exercise, right? Okay, so this is a rational number. Why? Because this is an integers and all integers are rational, right? This is a terminating decimal. It stops after 2 decimal points. So this is a rational number. This is an irrational number. Why? Because root 3 is irrational and it added with some rational, so it becomes irrational. It stays irrational. If it is add, subtract, multiply, divide, so it still remain irrational. Okay, so this is a rational number because it terminates after 3 decimal point. This is an irrational number because pi is an irrational. It is multiplied by 5. It still remain irrational. You can cancel the pi's and this becomes 4/3, and this is in terms of a by b form. So this is a rational number. Sorry. Okay, the next one is root 27. 27 is 3 cube, right? So 3 times 3 root 3 is basically 27, right? So 27 is root 3 is an irrational number. It is multiplied by 3, it still remain irrational, right? So let's simplify this. 9 times 1 is 9, and 9, 10, 11, 12, 13, 14, 15 and 16. So this is root 16 over 9. All right. So 16, root 16 is 4. 4 times 4 is 16. 3 times 3 is 9. 4 by 3 is in the form of a by b. So this is a rational number, right? Root 2 is irrational. It is multiplied by a rational. It still remain irrational. Question number 4, write down an irrational number between each pair of numbers. Write down an irrational number between each pair of numbers. Okay, irrational numbers, keep this in mind. Irrational numbers are the numbers which are not rationals. We cannot write them down in terms of fractions, right? The square root numbers and the pi, these numbers are irrational. Okay, number 1, between 3 and 4. Okay, so between, we can say 4a. So between 3 and 4, we can write down 3.1416. This is a number pi. So pi is an irrational number that lies between 3.14. Alright, so pi is a number which is 3.141592654. So this is this lies between 3 and 4, because 3.14, this is between 3 and 4. So the number pi is an irrational number that lies between 3 and 4. The second part is between 10 and 11. Okay, so for part B, between 10 and 11, what we can do, 10 times 11 is 111, 110. So root of 110. This is an irrational number. So whenever you have to find an irrational number between the two numbers, what you have to do, you can multiply the two numbers and take its square root, right? So root of 110, 110. And for part C, we can say 19 times 20. What is 19 times 20? So we can say 2 times 9 is 18, 2 times 1 is 2 and 3, and we have 0. So root of 380, this is also an irrational number. If I can do, as we know, 3.14, the pi value, 3.1416 and so on, this is a pi value, and this lies between 3 and 4. That is why I used pi. You can also use, as for part A, you can also use 3 times 4 is 12, and root 12 is also an irrational number. We can write down root 12 as 4 root 3. So 4 is a perfect square, so 2 root 3. This is also 2 root 3, or we can say root 12 is an irrational number. All right, so let's see with the help of calculator, are these irrational numbers? So if I can write down the number pi, this is an irrational and it lies between 3 and 4. If we can do 3 times 4 is 12, and root of 12 is 2 root 3, which is also an irrational number, non-terminating and non-recurring. 10 times 11 and its root is gonna be again non-terminating and non-recurring. It's rational. 19 times 20 is 380. Its root is again non-terminating and non-recurring. So without using calculator, you can guess the irrational numbers between two numbers by multiplying the two numbers and take its square root, right? Question number 5, write down the reciprocals of these numbers. This is pretty easy. The reciprocal of 5 is 1 by 5. The reciprocal of 1 by 4 is 4. The reciprocal of 2 by 3 is 3 by 2. The reciprocal of 7 by 5 is 5 by 7. Alright, the next topic, prime factors, we are going to cover in the next video. Stay tuned. See you in the next video. Take care.